Looks like we got Johnny and Grace online today, so feel free to speak up if you have any questions or use the chat there. Um, Make sure I have the chat. Oh, so today we're gonna do Unit 9, and we're really gonna try to take a deep dive into what I call subroutines as a generic term, but you might think of as functions or methods, how we pass parameters to them, kind of, and how we return values there. It'll kind of tie into classes because, again, to have methods in object-oriented languages, you need to have a class. So we'll kind of bring in all this stuff together here. I'll start just looking at some of the readings here from these two programming language textbooks I like to refer to. I'll tell you right away, I don't love their coverage of this material, and that's part of it is just to show you what's there and why we're kind of using AI instead of this. I think it does a little better job here. So this is Sebesta, and he has a chapter 9 on subprograms, and chapter 10 is on implementing subprograms. So he talks the implementation method is discussed in the next chapter here. But goes over, it starts with the basics. I never like when they go back to things like Babbage's analytic engine in the 1840s, but starts there. But talks about general, what is a subprogram, and that's the term he's using here, is a subprogram for this. And then jumps in and talks about what a function is a little bit in some of these languages. Tries to talk about parameters and the number order and the type of formal parameters here. It has a whole section on how parameters are set up here. Talks about positional parameters a little bit, which are what you're probably used to, and then talks about keyword, or sometimes called name, what I call name parameters here for this. And then goes in talking about procedures and functions, and then some design issues. And again, this is mainly looking at, not like in software design, where we're kind of looking at how we would use subroutines or functions to break up and divide up functionalities in a design, but just how do we how do they work? How do these actually work? So under that, we're going to look at things like local variables. So local variables are defined within a function, are only available then. So what does that mean for this? And again, most of the examples in this text are in C and C++. Talks about nested subroutines, like a function defined inside another function, and then goes through some parameter passing methods here for this. Passing information into a function or a subroutine, and then returning a value back, or doing both of these sorts of models. Talks about pass by value and pass by result here, and some options there, and also pass by reference. Talks about somewhat how these are implemented, and then goes over some common languages, including Algo, PHP, and C, and C++ for this. So, again, it's not a bad chapter, but again, it doesn't get into much of the newer stuff, which I am going to want to try to get into here. So, similarly, Scott has this subroutine and control abstraction chapter 8 here. That starts talking about the stack and how the stack is laid out here, and talks about, we have this stack in memory, and we put what we call new frames on it. When we call a function, we get that function's kind of frame, the local memory and the parameters and stuff, and stack and push that onto the stack here. So that every time a function calls another function or another method or another class, we load up that class into our stack. Have room for our local variables, or and then our functions or methods within that. So we kind of have this stack going on. This is not really talked about in terms of like classes. So this is like pre-object oriented stuff where we're just calling a subroutine or on top of a subroutine, things like that. Talks about some of the calling sequences, how we could do this. Thinking kind of looks at this idea of the stack in more detail with something called a frame pointer here. That's the pointer to where we are in our stack here. And sometimes we call it a stack pointer. It is kind of the current pointer. But then when we load in a new frame, a new function call, we'll save the old frame pointer that kind of marks the beginning of that here. And then any saved registers, some local variables, some temporary and arguments to the routines, those are all pushed onto a stack as the stack pointers here. So our stack grows up. And then again, we have our frame pointer as the start of that frame, and our stack pointer is at the top of that. Again, does case studies with Pascal and C here, two very old languages for this, and walks through those. Talks about parameter passing, different what it calls parameter modes, passed by value and passed by reference, and sharing of parameters, read-only parameters, parameter mode in a language called Ada, which is, I don't know, it's still used in some government operations, I believe. And then C++ is their probably more modern language for this. Okay, I'm not going to go too much more into this. I just wanted to kind of show you that, these textbooks, it's common for us to cover this topic here. How are we going to cover this? So I've given you some prompts to look at here. And I'm going to look at those today. So in the discussion area are the link to the prompts for this. But again, you can open up ChatGPT if you want and start these prompts. I decided not to provide right now the ChatGPT versions of it. I've been trying to decide how to get more engagement in this class. I think it might be useful for you to see these produced from ChatGPT, and it's really easy to do. I am going to walk through some of the Gemini responses here because Gemini is a little harder. Google's Gemini is a little harder to get because your CSS email can't get to it directly for this. It's always interesting to see at different times of the day how fast these things are compared to some other times of the day. So it looks like things are a little slow at ChatGPT. So I'm going to go back into this learning resource, and I'm going to click on these Gemini responses here. And those are done. And I'll just talk a little bit about those, and we'll compare those to what ChatGPT has. So first, what language do you use when you talk about writing a like a function or a method? What do you call it for that? Do you call it a function? Do you call it a method? What subroutine or procedure? What do you call it? You call it a function? You say method? Jeffrey, what do you say? What do you call these things? Like when you what? A method? Okay. Johnny and Grace? Yeah, method or function. Okay. That's good. I think those are more modern terms. I grew up calling them procedures, and I still often call them procedures because I'm old. What is the difference? Some subtle differences here. So subroutine tends to be a generic term for any of these, and that's why the textbooks sometimes use that term as subroutine. So it can be any block of code that we can execute for this here. Now, the way I was taught is that procedures are execute code but don't return a value, and functions execute code but always return a value for it. So they always have a return statement and return some sort of value with them here. And methods are always object oriented. So for you, I could see you always using the term method because I mean, everything you do probably is object oriented, or almost everything you do there. Now, I think in Python, you can define functions that aren't part of a class. Now, you really can't do this in Java. Everything's got to be within a class. So everything in Java is a method. But in Python, you don't necessarily have to have classes. You can just declare functions there. So in my mind, not everything is a method. A method is tied to a class there. It operates inside a class. So it basically is a function inside a class for that. And again, really, these are interchangeable in some ways for this. They can be used interchangeably. So, but just be aware that some people will tie methods inherently to object-oriented or classes, and functions tend to emphasize a return value for them. But nowadays, like even just it used to be you did have a return statement in procedure. You just wrote it. It didn't ever have a return. Nowadays on Java, I think you always have a return or an implied return there, even if it's returning void, it is still returning. And when you declare it as returning void here. So I think it's safe to call everything functions. So let's see what ChatGPT says. Yeah, procedure is sometimes called a void function. Performs action but does not return a value. And again, I learned this in Pascal. That's where I first heard the term and learned the term here. And again, subroutine is this more general term. I have to agree with that. So. I'm going to paste in this in the ChatGPT to get it going on that because I'm really interested to see what that says. Okay, let's talk about the stack and the stack layout here. So again, we take our stack and we divide it into what we call stack frames, also called activation records. There are blocks of memory on the stack. And what's stored in those? Typically the local variables for that functions, any parameters, the return address. So when we're done with this function, where do we have to go back to? Excuse me, save registers So again, often we have to save the registers in the CPU before we can execute some new code because we don't know what's in the registers. So I have to save a copy of the registers. And then the frame pointer is a pointer to the base of the current stack. And again, the previous frame pointer is a pointer to the previous frame stack, so we can jump back to that. So sometimes in my mind, the return address and the previous frame pointer are the same stuff, basically. So the frame pointer is actually a register, or we store that in a register and then we make a copy of it. It's just a location of the current stack, in the current stack, where we can access our local variables and things like that. So as we call a method, we put a new frame on there and we change we save the frame pointer and the previous frame pointer, and then we change the register to point to the new frame pointer so it can access the variables correctly. I'm not going to go over this example. I mean, this is just a generic example of a function, a main function calling an add function here for this. But let's just try to look at this. Well, I mean, that's the code. And again, this is just in kind of a pseudocode here. And then we can try to visualize this. So this is supposed to be our stack. And in main, we are storing things like X and Y here. We're going to destroy get end result is being stored here. And then the previous frame pointer is here. Now, when we call add here, we'll add a frame. So here's our previous frame here, and then we'll put the frame for the add function on top of that. So again, we have our previous frame pointer, which will point down to here. And then whatever's in here, we have A and B as our parameters and sum. So we'll have to store sum and A and B, and then the return address. So the return address is the variable when we return that we're going to copy the result into. So sum is here. When we return sum, we're going to copy that down to some variable. So we need to keep the address of that variable. So that return address is actually the address of result here because we say result equals. So that is the address of result, is the return address that we're going to send this back to. So again, that's what we're kind of talking about as we take these frames. Every time you call a function or a method, we drop this on here for this and call this. Now we'll talk a little bit more about classes in a little bit, because again, when we instantiate a class, we'll instantiate a class and the local variables on the stack. And then when we call methods within that class, we'll put this up, but they can also return to the local variables or the variables, the member variables in that class. So that gets a little more complicated than this. Call sequence here. Again, I think I went over that pretty well. I think I'm going to skip there. Let's just walk through this a bit again. Before function calls, we talked about the parameter passing. So we're going to save the caller's register, copy the parameters, or figure out how, we'll talk about different ways of parameter passing, but copy those parameter values in. We'll push the return address that we have to come back to when we're done onto the register, and then we'll jump into the code for this. And that will create a frame stack. We'll save the registers from here. We actually did that here. We'll just do it once. And set up the new frame pointer. Now we can access the parameters. We push the parameters onto the stack here, and now we can access them for this. So I'm not going to go over too much on some of these low-level details like registers and how some ways they are copied, but just be aware that Generally, you have to make a copy of the registers when you're calling another function or method. So, uh, so have you ever overloaded an operator like plus or greater than in your code so that when you that greater than or plus will mean something different when adding objects together? Do you know what operator overload is? Have you ever heard of operator overload? How about when sorting? Uh, how do you like? Let's say you're going to sort objects, uh, like employees, and you're going to use one of the standard sort algorithms for sorting your employees. So how do you do a sort with a class like employee? So generally, you have to define a function, a comparator function. Different languages do it differently, but you have to define a comparator function for that. I'm trying to remember how you do this in Java. Uh, would I use a uh, I think we use connection. Yeah, yeah. Right, you can use collections. So what is but you with employee, yeah, you have to define comparable or implement the comparable uh uh interface, right? Yeah, it implements comparable, and with that, you need a compare to. That's what it is, right? Yeah, so you have to define the compare to method. It has to be an override method, and then you can sort. So that's kind of like an operator overload in some other languages there. In other languages, you would actually override the less than or equals operator to check if they're equal. So like in C++, you can override all the operators. You can override plus. So you can just say one employee plus another employee, and maybe you add their salaries together. Maybe you'll do something else. Let's see. Let's maybe jump into the Gemini response to this sort of stuff. Oh, it's going to talk about generic stuff first. Okay, here's some override operators for us. So in Python, there's two special operators, and underscore underscore add and underscore underscore subtract for these. So you can define an underscore underscore add underscore underscore operator and on a class like point here. So then you can define 2 point objects. So that's our class point. You can define 2 point objects, and then you can just add them together with a plus here. So what is it going to do for adding points together? It looks like it is going to add the x's together and then add the y's together for that stuff. So that's what the add and that's what the subtract would also do. It's kind of like another thing you might think of analogous to this is when you override the toString operator. Right? In Java, you can override the toString, or you can define a toString operator, and then you can just print out your object, and it'll automatically call your toString operator. I think. Get all my languages confused sometimes, but if you just say print, system.out .println, and then you list an object, I think it'll call to print automatically. Not sure about that. So in general, JavaScript and TypeScript don't have operator overloads like this. And again, Python does have a number of operator overloads like this. But and languages like C++ do, a number of other languages do. So you can, when you declare, like when I was first learning to do object-oriented programming, I was taught in C++. And whenever we declared a class, we always defined the local variables, the getters and the setters, and then the operators. And we said, what operators are you going to need to add these objects together? Are you going to need to compare if they're equal? Are you going to want to compare if one's less than another? So we would define those operators. At the same time, we're kind of defining the getters or the setters. So we made this a nice object which can be used in lots of different situations. Okay, so far we've been talking about kind of general method calling here. This operator overload is the first time. So now we're seeing where the method is being called where we don't actually call it explicitly. So, you know, when you see this line, we're not seeing the add method or function being called, but we have to know that this plus is calling this method. So sometimes there are places where, you know, functions are called in a non-obvious fashion. So another thing that breaks or where functions are called or kind of broken is exception handling as far as the call stack goes. So let's just talk about what exception handling does to our call stack for this stuff. I'm going to post this in here too. I think. So again, normal execution, in a normal function execution, the stack frame is created and deallocated again, and this is the stack. So last in, first out, we just put it on top of the stack. Every time we call a function, we put the new frame on top of the stack. And when a function returns, we unwind, we pop that frame off the stack and unwind it predictably. Now, what happens when an exception is thrown here in our function? So we hopefully are using some sort of try catch to catch that. But and then we have to talk about this finally block and how we get that. Let's jump down to this Java example here. So here's our main method, and we're calling method A here inside a try block here. Method A goes down here. So again, we'll push the main onto the frame stack and we'll try it out. We'll call method A. We'll push method A onto the call stack here. And then we'll call method B. We'll push method B onto the call stack. Again, there might be local variables. We'd have to copy registers and that sort of stuff here for this. In these examples, there aren't any local variables to keep them nice and small, but you get the idea. And again, we're trying here, we're going to just divide by 0 to throw an exception. So that is going to throw an exception here. Now, we're not catching that exception. We're not doing it, but we are doing the finally block. So it should still do this, even though there was an exception. It should do this stuff. But then it will return here with the exception. The exception will be propagated. Well, it's not a return. The exception is sent back here. So again, we don't get down to return. We break, and here with it, the exception is propagated back to method A, and then it's propagated back to the main method here. And there's our try catch. So there we'll catch this and we'll print this out here. So again, method B throws the exception and the finally block is executed. The exception propagates through method A and back to the main where it's caught here. It's interesting, we don't need a try catch block in method A here because again, it's just going to propagate the exception back to where it was called from. And again, you can do the same thing in Python and TypeScript for these. So again, some important things. When exception thrown, normal flow parameter passing is interrupted. Parameters might not be fully processed here. Functions returns are not normally done. So if you're returning something, you're not getting a return back. The call stack unwinds. So the stack is, we propagate this error or this exception. And what we mean by propagate is we're popping frames off the stack until we get someplace which will catch and manage that exception. So we will, here we'll pop the method B will run, will generate the exception, has a final block, and it's going to try, so it'll propagate that. But again, we're not catching that exception. We're not doing anything with it. So that exception is propagated back to A. We pop that frame off. We pop B frame off, go to A. A is not handling it, so we pop A's frame off and go back to the main. Oops, I should be up here. Go back to the main here. And the main is finally catching that error and handling it. So now we don't, once we caught that error, we don't have to propagate that error anymore. It stops there. So we just keep popping frames off until we get someplace that's going to catch that error. That's why sometimes it's nice just to catch, you have to ask yourself when you're catching errors, do you want to just catch all errors or do you want to catch specific errors? Because you might have different errors getting pushed back. And you might want to just catch all your errors and log them or something at some point. So let's see how ChatGPT says. Yeah, they just talk again, same thing, talk about the stack frame. A function creates, when it's called, we create a stack frame. We push that onto a stack in normal execution, walks through the normal execution, and then talks about when an exception occurs here. So here we do a divide by 0. We push divide onto the stack. Here we call this. Here we generate an exception here. This exception stops execution. This frame, since it doesn't have a try catch block, will be popped off the stack here, and we return to the main frame. And again, we don't, I guess I shouldn't use the term return. We're not returning with the return statement. We just pop the divide method or, frame off the stack, and then we go back to the main frame. And we notice we are in the middle of a try catch block. So now we can catch that error. And again, I don't know if this helps you, but I think sometimes it is helpful to see, underlying this, how this works, because you probably understand already how error, exceptions are propagated backwards if you don't catch them here. But it just kind of, I think it's sometimes useful to kind of have a visualization of the stack and these frames being popped off the stack until we find some place that will catch that exception. Now, those are standard function calls. I wanted to talk a little bit about events and coroutines. I should have taken out the word asynchronous programming in here, I think, because when I did put this prompt in Gemini, it got really sidetracked with asynchronous programming, and all the examples were just how to do asynchronous programming with awaits and that sort of, and promises, that sort of stuff. And it goes over Java and that sort of stuff. And that's what I really didn't want to get into here. So I didn't like how it handled this. The beginning here sounds okay. Events and callbacks are important. So like when you use events and callbacks, like anytime you're doing your GUI interface, right? You're doing that. So I don't know what GUI you're using in Java these days. But again, if you have a button there, you're registering a callback or a function that handles that button click event generally. And again, we see this in, I don't know, did you guys take the mobile apps class? Right? And again, you might remember for every button on the screen, we'd register a callback function that would handle that click. Same in game design, if we have the user interface or some event happening. So even like a collision between two objects in a game, that will generate an event, and you could have a callback handling that event. And there's some sort of asynchronous nature to that because you don't know when your callbacks will be executed. It's kind of dependent on when the user clicks or when the arrow hits the enemy or something like that, and callback events are handled. So let's see how. Let's go back here. I asked the same thing if ChatGPT should have taken out the exception stuff. So yeah, it's kind of outlining events and callbacks. So a function passes an argument to be invoked later. Here, an event executes when an event occurs. It's kind of breaking those up. Let's talk about coroutines in just a sec too when we get into this stuff. So again, here they're showing how we do like an add listener to an event. So this is JavaScript. We're putting in a button here, and we're adding a listener to that for a click event, and then we're defining this method here. Now, this is actually using what's called a lambda function, and we'll talk more about those in just a sec. And often with callbacks, we'll use lambda functions in here. So this is the syntax for a lambda function, or an example syntax for a lambda function. Here, an anonymous function basically is what it is. Function without a name for this. Again, they're talking about a callback. Another place we'll see callbacks is like when you are doing some error of asynchronous activity, like you're doing a RESTful call to an API or whatever, and then when that call is done, you'll say call this function, or like if you're working with a database there, whenever that database is updated, you might get a callback, register a callback function where that callback function will be called then for this. So let's talk a little bit about coroutines. So coroutines can be functions that can be suspended and resumed for multitasking stuff. They can yield control to other coroutines or the event loop. So again, in most of these event-driven programs, there's an event loop that's running that's watching for an event here. So a coroutine is sometimes set up to do that. So again, coroutines can be paused and resumed in some ways. So we can let them run in the background for this, and it lets the rest of the program run while this coroutine is running. It's basically, it gives us the same kind of stuff as running this in a separate thread here. So, okay, so that was our ways of calling functions and ways functions are called in different ways. We're going to look at two different things. First, we're going to send messages to functions with parameter passing, and then we're going to get information back from a functions with return methods or something like that. here. Let's just talk about the parameter passing. I think you're kind of familiar with this. We've already kind of dealt with this somewhat. So there's a couple standard methods. Pass by value. You remember we talked about that earlier, where we just copy the value of the variable and send a copy of it to the calling method. So again, if we have this integer x a here, we call modify value a. It passes a copy up here. Even though we change x here, when we return a is not changed because again we passed a copy up to this. Pass by reference is when we're passing a reference to that object here. So we can have like here a list. So a lot of, in some languages, whenever we're working with a collection or a class, it's passed by reference. So now we're passing that reference up here. And then we modify it here. And that's the same list that's down here. So when we print it out. So again, those are the two common ones we've talked about, pass by value and pass by reference. You also sometimes hear the term pass by, pass by value reference, where we are passing by value, but we're actually passing the address of this sort of stuff. So sometimes they'll use some sort of combined thing where it's basically a somewhat different version of pass by reference. We're passing in a memory address here. So pass by name is where we just do more like textual substitution in things. So in some languages, we have what are called macros and stuff where we can do, where we can pass a parameter's value up there. And basically what it'll do is it'll, if it will basically, rather than saying take A and copy its value up here, it's basically going to say, oh, the variable is now called A, and this is now called A, and it'll basically do, like text substitution in the code to replace this. This is only really done in macros or in older languages, passed by name. And then passed by results. Formal parameters are treated as local variables within the function, and when the function returns the final value, the formal parameters are copied back here. So again, we basically make a copy of this, but then and work on it in our routine, in our function. And when we return back, we actually copy these back, reset those, and copy each one back by that. And again, that's really not used much. Like I say, not directly implemented in Java or Python or TypeScript or most languages you've heard of for this. So, and again, so Java, we pass by value for the primitive types. We pass by reference. Yeah, they're saying pass by reference by value. Well, again, we're passing by reference for objects. Okay. Now, how do we work when we get to more complicated situations like where we have name parameters, optional parameters, positional parameters, stuff like that? So I think you learn probably just positional parameters. So the order of the parameters is important. You have to pass them in a certain order for that. So again, that's pretty straightforward. So if you have, in particular with if you have an integer, let's say even this, if this was a string here, it's important when you call it that the first one is the integer and the second one is a string. The first position here is always copied into the first position here. The second position here is always copied into the second position here. That's probably how you learned parameters, right? So, have you used named parameters at all here? So, like in Python, we can say we can have parameters called the base and like the exponent here. Now, it can be treated positionally. We can pass in 2 or 3, but you can also say call this and say exponent equals 3 and base equals 2 and specify the name of the parameters and their values when you call them. And then you can put them in any order. So have you seen that? You've used that some? Yeah, these positional parameters here. How about variable number of parameters? So there's different ways of declaring this. So Python has 2 ways. The star. So if you put a star in front of a parameter, it's going to basically convert that into a list and assume you can pass in as many parameters as you want to this. So numbers will be assumed to be a list here. And then we can do like for num in numbers here. And then we can pass in 4, we could pass in 10, we could pass in as many parameters as we want with this star in Python. Star star will let us do kind of keyword or map stuff. So again, we can say print information, and then we can say name is Alice, age is 30, and city is New York. And then basically this will convert it into a key value pair. So we can do each key and each value with the items in this list or this map for this. So Python offers both of those. TypeScript has this sort of stuff where you can say ... numbers and declare it as a list of numbers and treat it like this. So again, Python lets you do that. And again, you're not declaring what type these are. TypeScript's going to be more type specific, so it's going to require you to call this an array of numbers for it. But then you can pass in variable numbers. It doesn't have we can't do this other key value pair. So. And again, Java, I don't know if you've done this with Java, but again, we can declare int ... numbers and pass in a set of numbers in Java also. So you can use this. This is the 3 ... syntax in Java for this. The other thing that we'll see sometimes weird with parameters is passing in the name or passing in a function as a parameter to another function for this. And this is often called closure. I think okay, so a closure is a function that that allows access to variables. So closure is when we're passing in a function as a parameter into another thing. Passing functions is parameters is core to functional programming, which I think we talk about next week. We get into functional programming and logical programming next week. But often you might pass in a function to another function. Often things like, if you're going to sort an array, you might pass in a function to sort or do something. If you want to do something to every element in a in a list, you might pass or you use that here and use what, again, we call lambda functions for that here. So like here's the Python example where we're going to filter and or we're going to print these numbers, but we're only going to print certain numbers. So we're going to pass in a predicate function that is going to do something. So here's our predicate function is called isEven, and it's a lambda function. We'll talk about more about lambda function in a sec. It has one parameter n, and then we check if n divide or mod 2 is 0, it means it's even, so that'll return true. So this will return true or false if n is even. So that's this even function. Now we can call this filter and print, pass in our list of numbers and pass in isEven here. IsEven will go up here and pass, and we will have our if statement, if, and we'll always run that function that we passed in on each number in the list. And then if it is even, we'll print it out. So this code would only print off the even numbers because again, we're passing in this filter function into this method for this. Now in Java, we can do something similar. Here's our main program. We have our array list. Actually, look at our list of values. We're defining isEven. And again, it's going to take one parameter. And then here's our function. If n divide or mod 2 is 0, that'll be true or false. And again, filter and print will pass in our numbers, will pass in isEven. So here's filter and print here. Here's our list, and here's our predicate here. And then we're using our predicate to call this test method. So in my mind, Java doesn't really have great closure in here. We have to use this predicate kind of method to do this, which is okay. Now I think, I'm sorry, I was just looking up in Java, something called reflection. So I don't know if you've ever gotten into reflection, but reflection in Java allows you to inspect and modify your own structures, your own classes and methods. So you can like pass in a method and do stuff with them with this. And sometimes when I've had to do certain things, like try to pass in a function, we've had to use reflection for this. So yeah, so reflection is a more powerful way of getting access to Java code within Java code, for example. Here. Did anyone do anything fun over break? A lot of excitement out there for break. I just relaxed. We relaxed in Duluth a lot. I graded a lot over break. I went to my cabin for a couple days for just overnight. So online students, you guys do anything fun? Just worked. Yeah, I can understand that. I'm doing some overload stuff. And so, yeah, my break was filled with more work than I wanted it to be. So, Johnny went to Arizona. So, Yeah, I didn't even get to Minneapolis. So usually we do try to get down there, but we didn't. So, well, okay. All right, let's go to the next section here. So we've talked about subroutines or functions, methods in general, and then some weird ways they are impacted here. We talked about parameter passing and things we can pass to parameters. Now we're going to talk about returning values. So again, functions, I'm calling this functions because functions have to have a return generally. Well, that's one way of thinking of it. It could be a void return. But let's look at how functions return a value. And again, this is just traditional stuff here. I'm going to grab this Lambda one because I want to ask ChatGPT that also. So you've seen this sort of stuff where we declare on a function in Java and we say it's an int rather than a void, and then we have to return a value here for this. And again, we get this in most languages here. Now, like in Python, we don't have to declare the type of the return, but we can do a return here. TypeScript, we declare a function, and these are the parameters. And then this is the type colon number, right? So this is the value we'll be returning for that. But all of them have the same way. You know, it might depend on where you put the value, if you have to put the type you're returning or not. But we're all returning some value here for this. So this is kind of the traditional way of doing it. And again, we work with the call stack. We're keeping with a function, we're keeping we're pushing the address of the return value where we want to return here onto the stack. And then when we hit this return, we'll copy this into that address before we pop off that frame and lose this. Because basically, this is the a local variable here, and we don't want to lose that. So we want to make sure when we do return, we copy that into the, the memory location in the stack below that called this the right location. So again, you can kind of envision this as far as the call stack works here. So now there are other ways of doing this. We can pass by results here where we can basically copy the local variable or the local variables within the functions the formal parameters are treated as local variables. When the function returns, the final values are. So there are some languages, and again, I'm thinking Pascal here, where and even C++, where you can mark some parameters as passed by result, meaning that they any changes you made to them will change that in the main program, in the calling program there. So those basically will all the parameters, not just the return value, but all the parameters are returned. Their values are returned here. So those are the main ones. And again, but nowadays we generally don't use that way, where most modern languages are, well, again, for pass by reference, that's kind of doing the same thing for this. So alternatives for this. Let's talk a little bit about this parameter modification. So generally, parameters are read-only here. So if we pass in a parameter, if we have some parameter called int radius, we change that here. It won't affect it down here in the main program. Our parameter won't be affected. Now, if you want to make sure you don't allow people to change things in Java, you can put the final here. and then they're not allowed to change this. I'm not a big fan of that because again, to me, this is just a local parameter here. We can use it in our local method and return and just know that that value won't be copied back down here. So in some places we can list things as in or out parameters for modifications here. And again, they're showing ones that are doing this with pass by reference here. So they're passing in an object with a value inside of it, and they're changing that value. So we can do this. Now, in my mind, I programmed in languages where you can specify whether or not you pass values just in or out for this. So yeah, so like, oh yeah, C#, that's where it is. So again, in C#, you can specify parameters as in or out or reference types here. So input parameters are only coming in and then you can't reset them. Output parameters are copied back out. So when you change them, that value is copied back to the main program here. So like in here, we're passing in A, B, and C. A is passed in to input. We can just use input. We can't change input at all. B is passed in as an output parameter here. And again, we can change it and it will change it here. So, I mean here, so when we print this out, it'll print out this output variable rather than the initial one here. And then reference means path by reference. So that also means we can change its reference for it. And then it'll change back down here. So that was C#. In C++, we can denote these with this ampersand, meaning pass in an address of a variable or not for this, and whether or not you can make that constant or not, meaning its input. So we don't use the words in and out, but we have a method for denoting these here. So on Ada, that's what it was. So in Kotlin, I think does that too. Yeah. Okay. So yeah, I wanted to capture that in this prompt, but this prompt did not capture that very well. So if you're working on your own prompt, you might want to look some more at in and out parts parameters here. Okay, so how else one of the challenges with functions is that it can only generally return one thing, or at least originally functions can only return one thing in languages like Java here. Now, in Python, we can return tuples. So you can say return 10, 20 here. And then you can say X, Y equals get coordinates. And then this will be done with order. 10 will be assigned X, 20 will be assigned to Y. So again, we can return these tuples here. And we can do the same thing in TypeScript here. In order to do something similar in Java or things like that, you really need to be returning objects. So again, what we'd have to do is we declare an object. We would create that object and return that object here. And again, you can, once you're with objects, you can do that in any language, any object-oriented language here. The other thing you can do is return a list of objects. I kind of wish they would have done this with these both not being integers here. Return like 10 and then a name, like a string, because you can also do this with two different types in tuples, I believe, here. And in objects, again, we can have integer and a string for different, member variables in an object. Collections work only, again, when we have all the, an array of the same objects. But maps will let us do key value pairs. So again, we're doing our key value pairs here for this. So name is Alice, age is 30. So sometimes that's helpful. So again, some ways of returning multiple values from a function. So lambda functions always confuse me. I'm hoping you understand them better than I do. I did not grow up with lambda functions here. So let's just talk about lambda functions here. So lambda functions are anonymous functions, functions that we don't give a name to here. So again, key characteristics, they don't have a name, so they're called directly. They can't be called by name. They have to be called right where you need them, right where you're going to call them. You define the function right there. They're often good for simple one-line functions, simple expressions, inline definitions, that sort of stuff. Although I've seen lambda functions that take up a whole screen, and I'm not a big fan of those here. So we'll jump back to functional programming later on, but they're certainly a key part of functional programming. Again, they're often used in higher order functions, like when we're trying to do a map or a filter or a reduce, where we're passing in some sort of function, often a Boolean function that'll be used to filter out certain results or stuff like that. So again, when we're passing in a function to another function for that. They're often used in callbacks for events. This mouse click, rather than saying when the mouse click, call the mouse click function, you'll just specify the function right in the callback. I used to not do it that way, but nowadays this is pretty common, and so I'm now doing it because and teaching that way as a good way of doing it, because it is the, I guess, industry standard, I'll almost say. So so let's look at some examples. This is like a filter or a map here. So we're going to we have a list, we're going to map, use the map function. It needs a function, so we're going to declare a lambda function. And again, we kind of condense the function definition down to like one line. So we would list the parameters, and then we do often a colon, and then the function itself. So again, here's the parameters x, here's the colon, and here's the function itself here, x times 2. So this is the whole lambda function here, parameters, and the return. Basically, this is what is being returned based on those parameters. So again, map would take this lambda function and then some list of numbers to apply that function on for this. Let's look at Java here. So here, again, we're doing the same thing. We're doing streams here. I believe we're doing streams here. So again, we're have our list. Yeah, we're converting that into a stream. And then with streams, we can do these sorts of operators on. We can do a map, or we can do a collect, stuff like that. So again, here's map, and then here's our Lambda function. And again, now we have our parameters, not a colon, but a arrow, and then the actual function itself for this. And again, we've seen those before up here. I mean, when we were looking at these before, I'm trying to remember where else we saw these Lambda functions, but they come up pretty regularly nowadays when you're working on things. Again, every time we do a callback, that callback is generally done with a like an event, a button click is done with a Lambda function. So yeah, here's the example of a button click in JavaScript here. So we're adding an event listener to the click event, and then it needs a function. So we could just put a function name in here, but here we're actually declaring a whole function. So that, see, this is where it gets confusing to me to get all the braces figured out here. So this is the add listener call. Inside add listener, this is the event, and this is that is the function, or the Lambda function. So again, it takes no parameters. That's what's here now. And again, we have our arrow to separate the parameters from the Lambda function. And then we're starting with a brace here. And then we're doing our log out here. Out here. So, sorry. Here, okay. I was wanting to see what ChatGPT was talking about as far as Lambda functions. So yeah, just walking through now. In Python, we say Lambda to define them, and then again we have our parameters, our colon, and then the function itself or the return value. So again, this would be a traditional version of this function, and this is a Lambda version of that same function. So basically, we're just, again, there's no name, and we don't have to say def, so this is ignored. So basically, it's just this, and then the colon, and then there's no word return. It is just this. So again, you can see how they did that. They just are taking basically this and putting it all together with the Lambda. I see these a lot, again, with Java, with streams and collections and applied for them. I don't know, where else have you used Lambda functions? Do you use them much? Well, you have to start watching and seeing. And again, I see them a lot with callbacks. So again, in mobile apps, when we're defining all of our clicks or button clicks or those sorts of callbacks, we would, often have a chunk of code that would be the callback, and we define a Lambda function for that. Sometimes we name them. I like them named, but again, the AI tends to use Lambda functions a lot. That's one thing I've seen is AI likes to use Lambda functions. So whenever I'm using AI, it tends to use Lambda functions more than I prefer, but I'm old. So, okay, let's go on. I'll just point, because I've been working a lot lately with the other kind of Lambda functions. So, so just be aware that Lambda functions are in programming languages are anonymous functions that you define here, but there's also this whole area of Lambda functions in cloud world, right? So in like AWS or Azure, there are Lambda functions, and Lambda functions there are serverless functions that you can run for this. And again, kind of this whole idea is that they're kind of anonymous, or they're not tied to a particular thing. They're serverless. So again, often if you just need to run, like when I first started using them, I was programming my Alexa, my little smart device. And again, in AWS, you program Alexa, so you give it some code and it would run, but I don't want to, generate. And you could have it run some procedure in some server, but I didn't want a server running all the time for my Alexa. I just needed, whenever I ran this particular command, have this one thing, this one function run on a cloud. And so again, in most of the cloud services, you can define Lambda functions, and you would just be charged every time they're run or something like that, rather than having to have a server up all the time to handle them. So they run serverless. So I just want to mention that that is the other type of Lambda function. It's in some ways totally separate from this. That's the cloud Lambda function compared to the programming Lambda function. Let's jump into object-oriented stuff. I'm gonna, I think, skip all. I mean, the basics you understand is classes and local variables and that sort of stuff. Let's talk about how we know, how the stack is working, particularly with reference to this private, protected, and public sort of stuff. So again, you're used to private, protected, and public allowing you to hide certain things within your class and stuff like that. Let's talk about frame management with this. So each method call creates a new stack frame, and we push it on the stack. Stack frames store the local variables. So those are variables within that method, not the method variables within that class there. So when we instantiate that object, we push it onto the stack with its method variables here. So, and then the access modifiers kind of dictate what you can access within that class or other classes. So, and again, when we return from a method, that stack stack frame is popped off the stack, but again, the whole class that's instantiated is still on the class, is still on the stack somewhere else. So okay, and I didn't really love this. I think I might have to modify this prompt. Okay, so as you're going through this, some things to consider, what do you want to look at some more? Do you want to look at some other languages? Some place I would suggest, consider looking more at Lambda functions or callbacks or this closure, passing in functions. If you want to look again at that. I kind of glossed over coroutines, so you might want to look at coroutines a little more for this. Overloading operators, if you haven't heard of that. So pick one of these that you want to explore and share that on Thursday in class. All right. Okay. Oh, yeah. We just got a notification of some internships at the YMCA in Duluth for the summer. So I'll probably post those two. The announcements are through relatively quick. They just came out, and there's 2 IT or computer related ones there. Now, I'll just warn you, the internships at the Y are you get a small stipend, but they're kind of volunteer internships to support that nonprofit. You get a Y membership as part of it, but we do have a process with the career services called ELF, experiential learning fund where you can get a stipend for doing this. So I'll post information on that too when I send that out. But I'll try to put that out today or tomorrow. So watch for those. Good. Those are options. And then again, we've had international students do those also. So also, if you're graduating and you're still looking for a job, let me know. And you should be networking with lots of people, and networking with me is a good place to start. So let me know if you're still looking for a job and where you're looking for a job if you're graduating in May. All right, let's stop this. Any questions online, folks?